Good morning, everybody. Um, I thought I would start the day with a cup of coffee and a video. Um, Today, we're going to knock out the functions that start with the letter J. There's only two of them. They're both simple and they're both uh, usable, and the juxt is pretty cool. So let's just jump into it. There should be no mystery with the join function. It's a list function. It's a curried, or I guess I should say optionally curried version of the join method that is on the array prototype in built-in JavaScript. Um, it simply takes a string, which is a separator, a list of A's, and it returns a string. So the join method takes an array and converts it into a string, and you can provide a separator to insert in between. We could say intersperse in between the array elements. So the string used to separate the elements. X's is the elements to join into a string, and it returns a string, and the string made by concatenating X's with a separator. So again, no mystery. Um, the only thing, I mean, let's just do it for completeness sake, but um, I'm going to use a taco. And then we could pass our data, and I'm going to use this data package that I created. The d.list is an array of 1 through 5, and we get 1 taco, 2 taco, 3 taco, 4 taco, 5. Um, we could also pass it like this. So we partially apply the function, we get the same thing. And then we could also, this is what's useful, we could make a function called const join with space and partially apply that with a string with a space in it and put a T right here because that's how JavaScript works. And there we go, 1, 2, 3, 4, 5 with a space. We could say join with comma. And I mean, this is useful enough that you could just add this to your own like little library because, you typically do stuff like this. Join with comma, 1, 2, 3, 4, 5, right? So very useful. We could also make this two different ways. We could do join with space, and we could say, um, trying to think here. Well, let's just make the join function. We could say join, and it could take a separator, and then it could take a x's, and then x's dot join with the separator, and then call it with a taco and our d.list and get the same thing. This is not optionally curried, this is actually curried. Um, and then we could also do it, just to drive back home a previous point, with r.invoker and invoker and pass it a taco. Or I'm sorry, first it would be, no, we don't pass it the taco. We pass it the number of arguments it takes, which is one, and then the name of the method, which would be on strings, and then we would, how would we do it? Then we would call it like that. Yeah, same way. Yeah, same way. So, this r.invoker does basically what I just did. What's cool is this is probably curried. It may not be like optionally curried, and it is. So that's one advantage. The way I did it was simple, but if you use this invoker, then first of all, we're doing it point three, and then we have the option to call the function like this, where we provide all the arguments at once, or we could do it partially applied. Sorry, quick sip of coffee. Um, so yeah, that's join. It's not sexy, but it's useful. Um, but we're going to get into juxt now, and juxt is really cool. It's one of these group by function. Um, the type signature looks a little crazy, but it really isn't. It's pretty simple. Let me just clean up this and clear my console, get to a starting point. So juxt, which is short for juxtaposition, which look it up. I don't, I know how to use the word in context, but I don't know the definition of it. Um, so what it does is it takes this array of functions and it returns a new function. The array of functions takes a variadic amount of arguments. It says variamatic, can't say it. Variadic arity, I guess. Um, I think you know what I mean, though. A through however many, and then it returns an n. And in this case, the n could be the same type as any of these letters here, but it doesn't have to be. That's what that means. So an array of functions, and then it returns a new function that takes the same amount of arguments and the same types as whatever you pass in, and then it returns a list of n's, right? And very simple definition, juxt applies a list of functions to a list of values, right? So, you know, normally we just take one function and apply it to one argument or to several arguments, depending on how many arguments that function takes. But there's a lot of situations where you're going to get some data and you're going to have to create several things from that data. Maybe you have a list of numbers and you have to add them together, and then you have to also multiply them together, and you have to add tacos in between the data, you know, several different things. You have to do this in three different steps, but this allows you to do it all in one line. So let me show you an example. So let's just start with r.juxt, and we need a list of functions. So let's do it like this. So let's say we had the number 32. That was our data. And what we needed to do is we need that number, we need the negative version of that number, and then we need, um, what's another one that we could do? Then we need to double that number, right? So for each piece of data that we get, that's what we need. We could do that very easily. So first, how do we get the number that we pass in? And this gives us a chance to use our r.identity, right? So we pass it a 32, and it's going to put 32 in the head of this list. And then we need the negative version. So we could use r dot negate. We haven't gotten there, but I think you could understand what this does. It's like multiplying by -1. You give it a negative number, it gives you positive. You give it positive, it gives you negative. And then we could, if we want to double it, we could use r dot multiply and pass it 2. And then we'll go ahead and just pass the data right here, keep it all inside this log. And there we go. And so what we get back is an array of the results. And then, maybe you don't need an array of results, but you could, map through it and pull them out and do what you want with them. Um, and so this output is a list, but it's kind of like a tuple or a tuple. Each element in the list has a specific type and purpose. Um, and you would expect when you use it with these three functions to have three results in order. So it's like an object, but they're just not named. And this is useful for when you have two or three things, more than three things, you probably want to name the arguments because it gets confusing, especially to people that haven't read the code before, or if you're coming back years later to look at the code. Um, so it doesn't just work on numbers, it works with anything. We could pass it banana, and we could, let's say we want to get the first letter, the head, and we want to know how long the word is. So we could get the length. And then we want the last letter. So we could use last. So we haven't looked at length, but length is like the dot length property, but it's a function. Length, and then you pass it something, and it tells you how long that thing is. Um, so if I did that correctly, let's run it. Yeah, and we get capital B, which is the head, 6, which is the length, and A, which is the last element. So this is the kind of function that I think is really useful, that is not just a curried data last version of something that already exists in JavaScript on a type prototype, like a string prototype or object prototype, array prototype. Um, yeah, so this one, uh, converge, which is something we looked at in the first series that Christopher did, um, and flow. Those are the three that I find extremely useful. Let's look at the explanation here. Functions is an array of functions. That's the first argument. And returns a function that returns a list of, or I'm sorry, a function that returns a list of values after applying each of the original functions to its parameters. Yeah, so just like a one-liner, you know. Otherwise, we'd say r dot head. Well, let's just do it. You could say, trying to think of what the good or yeah, good function name would be. Would you say get head? I would just say head. Head equals r dot head, and then banana, length, and what was the last one I did last? And then you would just like log head, length, and last. That should give us the same thing. It does. But here we could do it all, in one line. And then we could call this get stuff. I wanted it all in one line. We'll just call it stuff, just to keep it all in one line. Still isn't. Yeah, it is. And we can stuff our banana, apply stuff to our banana, get it like that. Same thing, but four lines in one line. This is pretty clean. And then obviously, if you were like, oh, I need the second to last letter, then you just stick a function right here. Very simple. It does say see also apply spec. So let's go and review that one because this one was also really cool. Uh, this one is similar. It takes an object where the key is a key, so it's going to be a string, and then it takes a function, and the function is the same type of thing. It's variadic as far as the arguments it takes, and it returns a value, and then you pass it a object. I'm sorry, it gives you back a function, and then when you call that function, it gives you back an object with a key value pair. And so I'm just going to use their example because we've looked at this before. And so what you're doing is you're basically, it's like you're saying, I'm going to get an object that looks like this. It's going to have a sum and a nested, and I'm going to give you some data. And for the sum, I want you to take that data and add it together. And for the nested, I want you to give me an object with a mul key, which is the result of multiplying the data together. And then so it's like, this is what I want. And then I'm going to give you an object that matches this shape. And then you give me the results. So we'll call get metrics with 2 and 4, log it. And then so we get that object with a sum of 6 and a nested, which is an object multiply 8. So what's similar about it is we're doing all these calculations in one go instead of spreading it out. Because again, like we did up here, we could just make functions, you know, one called get sum and one called nested, and then like return an object of the same shape where we say sum, and then we could use the function right here, or we could just pass the result into here. Um, so I see where they're coming from. So I'm going to throw this one in my list of favorite Ramda functions that are not built into JavaScript. So apply spec, converge, um, juxt, invoker. Those four are really cool, really useful. I've got my head wrapped around it, and I think I would use it a lot. And then, of course, the three magic ones I feel like are pipe, compose, and flow. And in fact, I very rarely will use compose just because I don't think right to left. But sometimes it feels right. So anyway, that's my favorite. If you've got favorites, let me know in the comments. And then that didn't take very long. So I think we're just going to press on and do these 2K functions, keys and keysIn, because they're very similar and not too difficult. So yeah, let's just press on. So keys, you give it an object with a key value, and it returns a list of the keys. You know, pretty straightforward there. So I've got this uh, d.obj, and it gives you an object with an ID of 1, a name of test, and an active of true. So just some built-in data from this some data package that I made. So we'll use that. And we want the keys So we'll do keys and pass in our d.obj, and we get an error. Because we need the r.keys. There we go. We get an array of the keys, ID, name, and active. So it takes an object, gives you back an array. Very useful as well. Now there is also an object.keys function built in. Um, so this does the same thing, but here we're doing it point free, and we don't have to say object dot, even though we're saying r dot, but you don't have to import Ramda. You don't have to import all of Ramda at once. You could just import the keys function. Then you wouldn't have to use the r dot name or r dot keys like a namespace. Um, I don't know too much to talk about that, but let's see if there's any tidbits of information here. It takes the object to extract properties from, and it returns an array of the object's own properties. So that is a very important piece. It returns the object's own properties. So remember, if you make something like a class, go with the classic person class, person, and we're going to say blah, 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 constructor. I always forget how to make classes. And we pass in a first and a last name. And good old this first equals first, who's on last equals last. And then we would do like um, get name. And so we got a method here, and we could return user backticks first base last. That would give the name. So if we used log dot object dot keys built-in function, oh, we have to instantiate object. We'll say Bob. That is a new person. We'll go with the classic Bob Ross. You know, that guy. And then we'd see what the keys are for that object. And we get first and last. But if we did this as, yeah, so that's exactly the same as this. But if we did keys in, right, which is the next function, I'm doing these kind of together, and we hit save. Object keys in is not a fun. Oh, yeah, we need to do r dot because there's no keys in on the object prototype. Okay, so that gives us the first thing too. And I think this is because we're using a class, but that's okay. I can show you where I'm getting at. If we did not use this class syntax, we just used a function called person, and it took in a first and last, and then we did the this dot first. Whoops. Now I'm going way back a few years. I haven't done this in forever. So like old school, right? And then we do person dot prototype. Like this is how we used to add on methods, and then say get full name and set that to a function. I'm going to use a function statement because that's kind of how we did it. Um, and we return this dot first. I'll even do it like this, plus a space, plus this dot last. Yeah, I think that's all I need to do. Pardon me if I've made a mistake. Yeah, so here we get first, last, and get full name because we're using keys in. But if we used object.keys, we just get the first and last because it says the object's own properties. And so this is like in the prototype chain, this is where it's like, oh, I don't see a get full name on this object that we created, this new person. Um, but if we go up the prototype chain, we find this get full name method. And then if we use keys in, we'll get that. And then the same thing with r dot. So r dot, sorry, I live in London. Somebody's just screaming outside and it's like 9:30 in the morning. Oh man. Um, yeah, so you know, that's the key. When you use the keys in, and this is like the reason they use the word in is if you did that syntax where you say name in person, which I've like never done. When I started using JavaScript, we already had map, filter, and reduce. So I never use loops. Um, but that's how that works. So since we've looked at this one, let's read the descriptions just to be thorough. Returns a list containing the names of all the enumerable owned properties to the supplied object. So when they say enumerable, they mean the properties of the object. Note that the order of the output array is not guaranteed to be consistent across different JS platforms. That is true. I've encountered that myself. If you try to loop through an object, um, sometimes the order will be the same, but sometimes it's different. And it could be different like within the same browser or across different browsers. So if you're ever needing to loop through an object, it's better to turn that into an array first and then loop through that, and then you can convert it back to an object if you wanted to. On keys in, it returns a list containing the names of all the properties of the supplied objects, including prototype properties, like that. Note that the order of the output array is not guaranteed to be consistent across different JS platforms, just like the other one. So this one says see also keys and values in. This one says see keys in values into pairs. And we're going to speed through those because they're all related and they're all simple. So this one, keys, we just looked at, that's right here. And values in takes an object with a key value pair and returns a list of the values, right? So it's the same thing, but it just shows you the values instead of the keys. Ross. But if we use values in, we get Bob Ross and then this function because the value of the get full name property is a function. So we could loop through that and maybe to string it or something. I don't care right now. We know that's a function and it's an anonymous function because it has no no name, and it doesn't take any arguments. Um, and then it says C keys in. We just looked at that. So that's the deal is when it says the word in, we get the prototype stuff. We go back. The values is going to be just like keys, but only showing the own properties, right? Bob Ross versus Bob Ross, and then the get full name function. Um, and then two pairs. And what this does is it's there's two pairs and from pairs. Um, if we did, see, we need an object. Let's get rid of person and just use the object from the e dot object. Oh, this one here, ID1 name test active true. If we use e dot two pairs, it's going to convert that to pairs. You know, it's right there in the name. D dot object, D dot two pairs, D dot two pairs. Oh, not D, R. Whoops. Yeah. It takes that, it was an object with a ID1 key value pair, and now it changed it to like a tuple ID1 name test active true. Um, yeah. And then, you know, if we took that, or actually I have one called D dot entries, which is pairs. It looks like this. D dot entries. Looks like that, right? A pair A and one, pair B and two, these little tuples or tuples. And then if we did from entries or from pairs, sorry, uh, again, doing the wrong thing, right? It takes our pairs and then groups them by object, you know. So object.keys and object.from entries. That's the built-in versions of two pairs and from pairs. So I know we got off topic and we're all over the alphabet, but those are all very related. And then we're done with the Ks. So we'll get into the Ls pretty soon. And I just want to like programming note. We've got last index, and length. And we've already looked at all of these. Excuse me. Um, we briefly looked at length, but there's not a lot to say about that. But when it gets into lenses, I'm gonna probably skip these. Um, they're a little bit advanced and require knowledge of functors and some category theory that I'm just not ready to talk about yet. Um, I'm not the guy to teach that yet. I'm still learning. So we'll skip these three and then jump into lift and lift in. I think I'll be able to handle these. Let me just take a quick look. Yeah, it talks about the Fantasyland apply spec, but we'll give it a go. And I mean, the worst that happens is I don't understand it and I delete the video after I record it. But we're going to do most of these. But we've done last index. So we'll get through. not too long, less than equal. Yeah. So anyway, that was the end of that was the J's in the case, and we'll pick up on the L's. So thank you for spending your time with me. Tell a friend. I'll see you in the next video.